Okay, I will proceed with the number 2 Roman. Okay, which the question is, find the steady state charge when the steady state current in an RLC series circuit when R equal to 1, R equal to 2, C equal to 0.25 and E equal to 50 cos t. Okay, first of all, we use the equation given, then we put all the information given such as L equal to 1, R equal to 2, C equal to 0.25. Then we get that 1, 2 and this one is 4 because 1 over 0.25 is equal to 4. Okay, then we use auxiliary equation equal to m squared plus 2m plus 4 equal to 0. Okay, then to find the root, the m, okay, we found that the root is complex number, so we have to use this formula. Okay, then we get that m equal to -1 plus minus Z3i, which alpha is equal to -1, beta equal to plus minus Z3. Okay, then we have to use this equation to get this. You have to use this equation since it is the third case. Okay, after that, to find the steady current and steady charge, we have to use to find a partial solution by using the method of undetermined coefficient, which is you have to since it is in form 50 cos TV, we have to use this equation. Then you have to derive this, and then second derivative you also have to use. You have to find. So you have to put it back in the original equation. Okay, after you get all this equation, then you have to put it back, and then you find that A equal to 150 over 13, B equal to 100 over 13. Okay, after that you put it back in the first equation, this one. Since you want to find the steady state charge. Okay, so you get a steady state charge is 150 over 13 cos t plus 100 over 13 sin t. For the steady state current, you have to derive the first equation, since you already find it, so you just put all the information such as A equal to what, B equal to what, then you find that the steady state current is -115 over 13 sin t plus 100 over 13 cos t. Okay, that's all from me. Thank you.